I will show you how to construct the orthocenter of a triangle. You'll need a compass and a straight edge. The orthocenter is the point of intersection of the altitudes of the triangle. And this construction uses construction number 4 as part of it. So if you're a little bit hazy on that, go back and recap it before you begin to do the orthocenter. The altitude of a triangle is a line perpendicular to a side of the triangle and that passes through the opposite vertex. Here's my triangle. I'm going to call it ABC. And a good first step in constructing the orthocenter is actually to take the sides of my triangle and extend them out past the existing triangle, like this. So I'm going to start by constructing a line that is perpendicular to AC and passes through B. This is essentially construction 4 that we've already seen. So the point of my compass goes at B, and I make sure that the radius of the compass is slightly greater than the distance from B to AC. I put the point of my compass at B, and I draw an arc through AC. This allows me to focus on just this portion of AC that I've highlighted in yellow, and by drawing this arc from B, I've ensured that B is directly over the centre of this yellow portion. Now I go ahead and construct a perpendicular bisector for this yellow bit as I normally would. I first check that my compass is open to more than half the length of this portion, and then I draw my arc above and below from the left hand side, and then I switch and draw my arc above and below from the right hand side. I then get my straight edge and I line up the points of intersection of the arcs. When I'm actually drawing the line here, I'm going to draw it just from the line AC and up so that it touches the point B. And if I've done it accurately, it should be going through the point B. I'm now going to repeat all of these steps for a second side of the triangle. So this time I'm going to construct a line that is perpendicular to BC and that passes through A. I first check that my compass is open to greater than the distance from A to BC, and then I draw an arc through BC. Now you can see in this case, in my construction, that my arc actually landed outside of the triangle, and this is the reason why we should extend the sides of our triangle before we begin. But it's not a problem that it's outside the triangle. I'm just going to include this portion that I've drawn as a dotted line as part of the line BC. So now I'm going to focus on this portion that I've highlighted in yellow. Again, at this stage, I'm just constructing a regular perpendicular bisector. I'll start by checking that my compass is open to more than half the length of this yellow portion. And then I'll draw an arc above and below the line BC. Have I done the same thing again? Oh, that's all right. And then I'll go to the other side, and again I'll draw an arc through that yellow portion. Now I'll take my ruler or my straight edge and I'll line up the points of intersections of those arcs, and it should line up with A. When I'm drawing the line here, I only need to go from the side BC over to the point A. Note that in both cases the lines that I've constructed are perpendicular to the sides of the triangle. So really these two lines here that I've constructed are actually the perpendicular heights of this triangle. And the orthocenter is the point at which they intersect.